Okay, in the second video, just want to go through the steps. So let's say, for example, we are somebody standing up on the top of a building and dropping a ball. So maybe the initial height is, let's say, 50 meters, going to drop from rest. I just want to illustrate how we use the Euler method to estimate how the position and velocity are changing with time. So let's just make a little table here. So I would be our step number, t would be the time at that step. We have y, vy, and ay. And so we're just going to assume for simplicity here, our delta t will be a tenth of a second. Let's actually make it 1 second. It's kind of big, but just to illustrate the point. And then our acceleration, we'll just say, is minus 10 meters per second. Again, just to kind of make my math easy. So let's say when I is 0, that's our initial condition. T is 0, y is going to be 50 meters. These would be in meters. Our velocity, we said, would be just 0, and our acceleration is always the same. It's 10 meters per second squared. So our units there. Okay. So now let's see how we would step through the Euler equations. So let's say we want to know what V1 is. It's going to be V at the previous step, so V0 plus A0 delta t. V0 is 0. Our acceleration is minus 10 meters per second squared. Our time is 1 second. And so V1 is minus 10 meters per second. So I can put that in here, make another row for 1. And that's going to be minus 10. And acceleration is always going to be 10. My position, x1, is the position at step 0 plus velocity at 0 delta t. So position 0, sorry, these should be y's. I'm getting confused here. Okay, so 50 meters. My velocity initially is 0, so this is just plus 0. So y1 is also 50 meters. And t, we're stepping by 1 second, so it's going to be 1 second here. And let's do one more for when I equals 2. So v2 equals v1 plus acceleration at 1 delta t. So v1 is minus 10 meters per second. Our acceleration is negative 10 meters per second squared. Delta t is 1 second. So velocity after 2 seconds is minus 20 meters per second. That's going to go in up here, minus 20. Our acceleration is always staying the same in this example. Okay, and then y2 is going to be y1 plus v1 delta t. So y1 is 50 meters, v1 is negative 10 meters per second, and my delta t is 1 second. So 50 minus 10, my position after 1 second would be 40. And my t is going to increase by 1 second again, so it would be 2 seconds. Okay, so these are really big time steps, but just to show you how we use these, how we could actually really calculate by hand using the Euler method the trajectory of a projectile or whatever we wanted to follow.